All right, so in 11-6, our topic here is going to be tangent lines. So tangent is, a tangent line is a line that hits the circle at one point. So if you've got a circle that comes over here and hits the, or a line that comes over here and hits the circle at exactly one point, that's called a tangent line. So notice that it can't go into the interior of the circle, because if it goes in, it's got to come out, and then that would be two separate points. It wouldn't be a tangent line anymore. So a tangent line, that's a different word, tangent, from like sine, cosine, and tangent. That's two different things. So tangent line hits the circle at one point, just comes and barely hits it. Okay. Now here's a theorem. A radius is perpendicular to a tangent line when they hit the circle at the same point. So a radius is perpendicular, 90 degrees, to a tangent line when they hit the circle at the same point. So if a radius hits the circle at the same point that the tangent line does, the tangent and the radius are 90 degrees to one another. Okay? Here's another theorem. If two segments from the same exterior point are tangent to a circle, then those segments are congruent. They're congruent. So if I have two segments from the same exterior point and they're tangent to a circle, one's tangent on this side, one tangent on the other side, those two have to be the same length. So if this is 10, this is 10. 8, this is 8. All right, here's another thing to consider. If it's drawn like this, this is not a tangent segment. A tangent segment has to be a part of a tangent line, and this line would not be a tangent line because it hits the circle in two places. A tangent segment has to be a part of a tangent line. Okay, so keep that in mind. All right, so right here, what if I wanted to solve this? Okay, so two tangent segments come from the same exterior point. That means that 2x has to be equal to 30. Those two are the same. You can now go in and divide by 2. And then what would you get? You get x equals 15. All right. So remember, when they come from the same exterior point and they're tangent, you got to be equal. All right, what else we got? So we've got some problems here where we're going to have to be asked to find x. So here I've got 16. Okay. From here to here is 30. From here to here is x. I'm trying to find the value for x. Okay, so on this one, I can actually just set up a straight Pythagorean theorem. X is the hypotenuse. That would be c. So it'll be 16 squared plus 30 squared equals 2x squared. All right, so here's an equation that we can now solve for x. If I square both of these, 16 squared is 256 plus 30 squared is 900, and that's going to be equal to x squared. All right, I can add those together and get 1156 is equal to x squared. Let's take the square root of both sides, and my x is going to be equal to 34, and then there is your answer. All right, so that's just a straight Pythagorean theorem. You've got right triangle, c is the hypotenuse. All right. Okay, now this one's a little bit different because here I've got 18, here I've got x, and from here to here is 12. Okay, this is not x squared plus 18 squared equals to 12 squared because 12 is not the entire hypotenuse. So we have to be careful here. Okay, I do know that x squared plus 18 squared would be equal to the hypotenuse, but the problem is the hypotenuse is not 12. 12 is only from here to here. If I had a way to get this other part, I could add them together. Okay? And I do have a way to get the other part because remember, this is a radius, right? Well, how much is the radius? It's 18. Remember, any radius you draw is going to be the same in the same circle. So if this radius is 18, this radius also has to be 18, and any radius of this circle would be 18. So that's a key concept that's going to kind of play out several times in this chapter. Is the fact that once you have a radius, you have any radius of that circle. If this one's 18, this is going to be also 18. Now I can add those two together and make the full hypotenuse 30. And now I have the complete equation. All right. So to finish it, we'll go x squared plus 18 squared is 324. 30 squared is 900. So I need to move the 34 over to the other side. It'll change from plus to a minus, so I'll go x squared is equal to 900 minus 324. And when I do that, I've got x squared is equal to 576, square root of both sides, and my x is equal to 24. Okay? All right, so that's what we've got. So again, it's just using the radius in order to finish up the equation of what we need. Okay, so here's another one now. And so at this point, I've got an x here. Okay, I've got a 24 here, right? I've got a 32 here and here. So how are we going to set up an equation that we can find x? Well, number one, I need to try to make one right triangle out of this, right? And in order to finish that equation, I know that, again, if this radius is 24, that this radius is also 24. So there's the key concept. And now I've got a right triangle where I have all of the sides together. So I know that 24 squared plus 32 squared equals to x plus 24 squared, but I'm not going to write it as that. Now let me tell you why. Because if I wrote it as x plus 24 squared, I'd have to square it out and then solve it. And that makes the equation much longer to solve. Okay. What I can actually do to save myself some work is just say that that's equal to c squared, solve the c, see how long the whole hypotenuse is, subtract 24 from it, I'll get my answer. That would be much easier than writing it equal to x plus 24 squared and then having to square all that out. That's a lot more work. Okay, so I'm just going to say that that's equal to the hypotenuse squared, see what the hypotenuse is, subtract 24 from it, and then get my x. Okay? So 24 squared is 576, plus 32 squared is going to be 1024, and that's going to be equal to c squared, so we can add that, 1600 equals to c squared, square root of both sides, c is equal to 40. And so if my hypotenuse is equal to 40, then I can do 40 minus 24, and then that means my x is actually 16, because 16 plus 24 makes 40. All right? So there you go.